Hi everybody, welcome to the first example presentation. We're going to show how you might present Euclid's proof of Book 1, Proposition 1. That given a segment, one can construct an equilateral triangle ABC using a compass and straight edge. So let's start with a segment AB. Our first step is going to be to draw a circle centered at A going through the point B. We can do this by postulate 3, which allows us to draw a circle, and in fact tells us how to use a compass, basically. Similarly, we're going to draw a circle BA. That is, a circle centered at B going through A. Now, we're going to get a new point called C, where the two circles intersect. How do you know that they meet? Well, we're going to be using here a kind of postulate called the circle-circle intersection property, as discussed in the first notes. Now I've chosen C at this bottom point where it's on the picture, but of course there could be a second point way up there. Doesn't matter, we only need the one. Now we're ready, we just need to draw the triangle. Here it comes. We'll draw in the two segments, AC and then BC. That's going to complete our triangle. And we of course can draw those segments using postulate 1. Which tells us how to use a straight edge. Now the important thing is that AB is congruent to BC. And this is because both of those segments are radii of a similar circle, that is the same circle, circle BA. And entirely similarly, we can see that AB is congruent to AC, because they're both radii of the circle centered at A that we drew before. So that means that the top segment is congruent to the segment on the right and also to the segment on the left. So by common notion 3, since those two segments are congruent and these two segments are congruent and the one in the middle is the same, all three segments are congruent to each other. That means that our triangle is equilateral, which is what we wanted to prove. So the proof is complete. And we are done.